So in lesson 83, we're going to be integrating even powers of sine x and cosine x. Several lessons ago, we worked through integrating odd powers of sine x and cosine x. So now we'll be looking at things that deal with even powers. Because in the last one, if we had any odd power, we could use the ideas we had last time. We ended up using the Pythagorean identities. The ones that we'll work with today will only have even powers. No odd powers that are just even, because the other ones, if we had even and odd, we could go ahead and do the other method. So what we have here to start with are two identities. We may not have seen them in this form before, but they're not brand new. If you look back, you can look at your half angle identities, and we learned that sine of x is 1/2 minus 1/2 cosine of 2x. And so what we could do is square both sides and we would have this function. Same thing with this bottom one. We would have this. Another interesting way to look at functions or see if one thing is equal to another is we could put y equals sine squared of x. We could graph that, graphing calculator or some computer program. We could graph y equals 1/2 minus 1/2 cosine of 2x, graph those on the same axes, and you'll get the exact same graph. So these two things are equal. Cosine squared x equals 1/2 plus 1/2 cosine of 2x. And so we'll be using those identities in these different examples that we'll be looking at. So coming to our first example, we're going to integrate cosine squared dx. And we're going to start off by making this substitution. We're going to take the cosine squared x out and put in 1/2 plus 1/2 cosine of 2x. And now we can integrate that. We're integrating a sum, so we can just integrate the parts. So the integral of 1/2 x is, of 1/2 is just 1/2 x. Our next part here, the main function here is a cosine function, so the integral of that is sine. So we'll put sine of 2x. We might have to change something. We'll check this to see if we need to multiply it by some extra factor. So we'll check. So by taking the derivative, 1/2 x is just 1/2. The derivative of sine of 2x is cosine of 2x times the derivative of 2x, which is 2. And derivative of c is 0. So let's go back and look. This is correct. We got a 1/2. And we do have a cosine of 2x, but this has a 1/2 and we got a 2. So what we need to end up doing is multiplying our solution here, our answer, our integral, by 1/4. So therefore, when we come down here, 1/4 times 2 gives us that 1/2. So here is the integral of cosine squared x dx. Moving on to another one, this has two even functions, and so we can't use our other method. Or maybe we could, but here we're just going to use this method that we learned today. We can go ahead and substitute. So using our identities here, we got a 1/2 minus 1/2 cosine of 2x. And then for cosine, we have, really it's the same thing except it's a plus sign. Dx. Now what we'll do is we'll multiply this out. This works out really nicely because this is in the form a minus b times a plus b, and we know that we get the first thing squared minus the second thing squared. So we got a 1/4 cosine squared 2x dx. And we're back to we have a squared in here still. So now we're going to actually substitute a second time. And we're going to use the cosine squared. So we can bring a 1/4 out right now. So we got a 1/4. And we could have left it in there till the end, and we'll see how it pans out. We got a 1 minus. So instead of writing cosine squared 2x, we can use this, except we have to realize this is a 2x. So when we go to put this in our formula, that 2x really goes in for this x here, because our formula has for just a 1x, so we have a 2x. So we'll have 1/2 plus 1/2 cosine of 2 times 2x, which is 4x. Distributing the negative, and then going ahead and use that. So we got a 1 minus 1/2 is 1/2. And then we have a minus is distributed here, so negative 1/2 cosine of 4x. And I forgot our dx. And once again, we could factor out a 1/2. Let's do it. We don't have to, again, but let's go ahead and do that. We haven't even taken the integral yet. We are just putting it in a form that's going to be easiest to work with. And so now we have 1 minus cosine 4x dx. We'll go ahead and integrate. We got a 1/8. We'll come up here, 1/8. And the integral of 1 is x. And then this is a negative cosine. So integral of cosine of 4x, we're going to go ahead and say, well, this seems like it's going to be a sine of 4x. And distributing, we get 1/8 x. Oh, I'm sorry. First, we want to check this. We'll check our integral here, and then we'll go ahead and see, or we could distribute that 1/8 through there. So we'll check our derivative. Derivative of x is just 1. Derivative of sine, our negative sine, is cosine of 4x times the derivative of what's inside, which is 4. So comparing this to this down here, we have an extra 4, and so we need to multiply our answer by 1/4. And now what we'll do, now that we have that checked, we'll come down here, we'll distribute, and we get 1/8 x minus 1/32 sine of 4x. And we'll squeeze in our plus c. And there's our answer for that. Did take us a while. Part of it was factoring out a few times, took an extra line, so maybe if we hadn't factored those out to start with, it would have shortened our work there. Our last one here that we'll do an example for is sine to the 4th x dx. And what we'll do here is sine to the 4th is really, and maybe we wouldn't have to write this work as we get a little better at this, but this is a sine squared x squared dx. And so we'll substitute in 1/2 minus 1/2 cosine of 2x, and this whole thing is squared dx. Multiplying this out, our rule, or our pattern that we have, if we have a binomial squared, it's the first thing squared, and then it's the first times the second doubled. So a 1/2 times a 1/2 cosine 2x is negative 1/4, but we're going to double that. So a 4th doubled is back to a 1/2. And then the second part squared, the b squared. So we have plus 1/4 cosine squared of 2x. And just like we had to do last time, we had another squared here, so we're going to substitute again. This time I'm not going to factor any of these constants out. So we got a 1/2 cosine of 2x. We'll be able to integrate that. And then here we got a plus 1/4, And cosine squared 2x is, we're going to use this identity. Again, it's not an x in here right now, it's a 2x. We could even think of this as a u if we wanted to, if that's more helpful. It'll be 2u. And so when we put our cosine of 2x here, we have to put a 2x in for u. So this is going to be 1/2 plus 1/2 cosine of 2 times 2x, which is 4x. And this is all dx. I might have added, nope, I think we're okay. And then simplifying our last term here, with this 1/4, we have a 1/8, and we'll work with that in a minute. 1/8, and then plus 1/8 cosine of 4x. And so now we're just about ready to integrate. One thing I'm noticing here, it should be a bracket, is we have a 1/4 plus a 1/8. So instead of writing a whole nother line, a 1/4 plus a 1/8 is 3/8. So I'm going to go ahead and get rid of this, and we'll put a 3/8 up here. And now we can integrate. We have a 3/8, so the integral of 3/8 is 3/8 x. We've done this a couple times, or we've done this one before, so if we remember this, it might help us. But let's go ahead, we'll just say we think this is going to be a sine of 2x. And let's think through this already. And again, we did this one before, but when we take the derivative of sine of 2x, it's going to be cosine of 2x times 2. So we would have a 2, but we need a 1/2. So we need to multiply this by 1/4 to get the correct factor out there. And this one here, we're going to go ahead and say this is going to be plus sine of 4x. And thinking through our check, derivative of sine of 4x is cosine of 4x times a 4, but we don't want a 4, we actually want a 1/8. So in order to get from a 4 all the way to a small 1/8, we have to multiply by 1/32. And then we have plus c. And so there is the integral of sine to the 4th x. And so if we have even powers, we can use this new strategy. We have a couple of identities here that we can use. If we have to multiply things out, sometimes we got another squared function, a cosine squared, so we use this again. And we realize that we had to substitute a 2x in for this u here, which I changed it to. And that's it for integrating even powers of sine and cosine.